mean was 493, is that correct?
Yes, that's correct.
And the standard deviation shouldn't be that. Well, it could be that. It doesn't matter. I know this is wrong because this is a mean for a what? Sample. This is a mean for, or the standard deviation for population. I think it was 111, wasn't it? First thing I want to do, I want to draw this. You guys got to be able to draw these. All right? You don't have to draw them on the quiz, but you have to be able to draw them because I know in the next test I make you draw them on everything. What's going to go right in the middle here?
493.
493. What goes right there? Have your calculators out to help.
This is like 604 or something like that.
604.
I forgot.
What goes right there?
715.
7 what?
15.
15. What goes here?
826.
Everybody can do that, right?
Yeah.
What goes there?
382.
382. What goes here?
271.
Say what?
271.
271. And the last one?
160.
One what?
660.
160. Everybody can do that. Remember, this is a normal distribution. What if we want to change it to a standard normal distribution? What goes right here? What goes here?
1.
What goes here?
2.
Here? What goes here?
-1.
Here?
-2.
Negative, exact same curve, normal distribution, standard normal distribution, all right? I don't know what the question asks, I need to read it. What percent of SAT scores are less than 600? Get your calculators out so we can do this. We want less than 600. I think in your calculator, we have to punch in, what do we have to hit? Second, bars, is that correct? And then we hit, what do we,
2.
number 2, is that the one?
Yeah.
What's it say?
Normal CDF.
Normal, CDF. And then it asks us to type the stuff in, right?
Yeah.
And we type in our low limit, our high limit, our mean, and our standard deviation. This time, if we said, what did it say, 600 or less? So we're going from 600, that's here, and we want all of this area. So what do I put in first? What's my low limit? How low out here am I going?
-1,000.
Something. Now, do you really have to do -1,000? If
Not
we're at
really.
160, this is why I did 10,000. Because some of the numbers we deal with get big, and we want to be way up there. On ones like this one, use your brain a little bit. Could we just put in 0? Yeah. So if you wanted to just put in 0, that's going to work the same as -10,000 or whatever. Right? Any number that you put in. If Gage isn't listening to me at all right now, and he just says, I'm going to put in -10,000 every time, Ebersole. I don't know what you're saying right at the moment. Who cares? Go right ahead. It's going to do the same thing. What's our upper limit? 600. What's our mean? 493. And what's our standard deviation? 111. What's that tell us?
0.832.
Go out 4 places every time.
5.
5.
Well, if you
Round.
Now, I see a lot of you are changing them to percents, and that's fine to change to a percent if they ask you to change it to a percent. Don't change it to a percent just because you want to. All right? On this one, let's see, 21. What percent? So what is our actual answer here? 83.25%. So if you take the SAT, what's the probability that your score is going to be 600 or less? About 83%. Now, unless your name's Brendan, then we know that that's not the case, because it's
Right.
gonna be a lot higher than that.
Of course. 1,200.
What's the ACT, or the SAT out of?
24.
It's like 2,600 or something, is that what it is? 2,400?
That seems like an
80% scores
Yeah.
like
Yeah.
600.
That seems like a really low score.
Yeah. I thought it was like 1,600.
Part B.
I thought you got like 600 points for writing your name.
Yeah, I think you get 400 for writing your name. Yeah, that's.
Part B says, if 1,000 SAT writing scores are randomly selected, about how many would you expect to be greater than 550? First thing we gotta do on this time we want greater than, not less than, we want greater than 550. So what's gonna change on this stuff that we're putting in our calculator? What's the low one gonna be? 550. What's the upper one gonna be? This time, because we're going out that way, I don't know, you heard me just say 2,600, I don't know what the top score is on that ACE or SAT. So we want to go higher than at least 3,000 or something, right? Because, so this one I would probably put in 10,000. Just to make sure, because I don't know what the upper limit is. And then the other stuff stays the same. What's that give you? Give me 4 places again.
0.3038.
So everybody agree with that? So what's the probability that you're going to score higher than 550?
30.
About 30%. Now, is that what they ask us for?
Yeah.
No, they ask us if 1,000 people took it, how many of those scores would be higher than 550? So what do we do with that?
303.
Take that number, and you already got it right there in your calculator, right? So all you got to do is hit times 1,000. Now, probably you don't even really need your calculator, because if you're multiplying by 1,000, what are you actually doing? Moving the decimal over 3 places. So about how many people? About 303, 304 people.
That was my question.
Is what to do when it says like get out of this one.
That's number 21. So yeah, you just you take your probability, times it by how many people or how many whatever it is that you're doing.
Yeah, because I just found the percent.
So you understand how to do it now, right?
I said you,
Alright, with.
you would always run to a whole wide system?
Well, if it, it depends on what it is. If it's a person, yeah, probably so, because we're not going to have 0.8 of a person. If it's cows, then yeah, probably so. You're not going to have 0.8 cow laying out in the field somewhere.
If it's like pounds.
If it's in pounds, ounces, something like that, yeah, then maybe you don't. Okay?
I didn't feel like I could do that.
You just you have to use common sense. Hey, is this a number that needs to be a whole number, or is it a number that doesn't necessarily have to be a whole number? Is everybody ready?
Yeah.
Yes,
All right. You can use your binders, notes, all that stuff. You cannot use your neighbor. If I see you talking, I'll just give you a 0. Calculator. I trusted you, Sean.
Sean had it done.
I don't like it
before
that
we
kind
went
of
to
trust.
class. Or most of it at least. We checked it. I'll say you had most of it when we checked.
Well, yeah.
I forgot to do this, so I'm going to do this on the board here real quick. It's really unnecessary, but I'm going to do it anyway. Three questions. They shouldn't take you but 4 or 5 minutes. You get finished, turn them into the tray up there. Again, you can use your notes, you can use your homework. Calculator, can't use your neighbor. And you're welcome, Mike. I didn't say it. trend.
If you guys could only win one game all season, then I want it to be this. Yes. I know, but if you guys could only win one game, I'm ready to hear this one. Yes.
Can I change my answer?
You better do it real quick. No, hold on. Is he back here cheating? Is he asking somebody else?
I did ask.
Is he cheating?
I did ask.
Yeah.
I don't have my notes with me. I couldn't remember for the life of me what a Z-score is.
I did it, and I feel like I did it wrong.
I got my anatomy
I don't know
stuff.
what the last one was.
Do we want to go over the quiz or should we just go on?
I'm good. I know I got it right.
Going over the quiz on the first one. And I changed it. What's the mean for a standard normal curve? 0. What's the standard deviation? 1. The second one said find the z-score, right?
Yeah. 0.
If you didn't have, your notes, and you should have this in your notes somewhere, z equals, what was it again?
It was like x means minus x.
X minus, 1 second, x minus the mean over standard deviation. Now that's going to be important because what we're going to do today, we're going to go the opposite way. Yes. Yes. Brendan, they want you in the office. Tell me, you ain't got time because Ebersole's class is very important.
Who cares about your futures?
Right.
So we're going to turn this around and do it the other way. Instead of finding the z-score, they're going to tell you the z-score, and we're going to find x. What was the answer on this one? If you drew out the picture, I seen Gage over here drawing out the picture, and that was something I was hoping nobody would do because I didn't want him to figure it out that way. I wanted him to have to actually use the formula and think it through and then think, oh crap, I could have known that. But he drew out the picture. If you drew out the picture, where was 30 located at?
Right in the middle.
Right in the middle. So what's the z-score that matches up to that? 0. And the last one, this is another important thing that we're going to do today. P20. 20th percentile. You got to know that. And what that means to what we're doing is if you're in the 20th, or if a score is the 20th percentile, that means that it's higher than what percentage of all the other scores? 20%. That means that score, whatever that score is higher. So now, as we're going through this today, that's going to be very important because they're going to give you something like 20th percentile, and you're going to have to figure out what score that matches up to in relationship to a z-score or a raw score. Normal distributions and finding values. So now instead of finding the probability that something occurs, You write down what you think you need to write down. Let's see. Well, hold on. Yeah, I might be wrong. Yeah, these are just the objectives, so probably not. So what we're going to do is what I just said. We're going to find a z-score given the area. So before we were taking a z-score, finding the area. Now we're going to go backwards to that. Transform that z-score to an x value. So you're going from a standard score to a raw score, which makes more sense to most people. If I tell Phoenix that his standard score was a 2.1, it's not going to mean a whole heck of a lot to him, right? I might do that on the next, I think I will do that on the next test. I'm going to put your scores on your test, and I'm going to put them as z-scores, and then if you want to know the actual percentage, you're going to have to change it to a raw score. We'll do
Look
that.
at my grade on Google.
So kids
I'm
who get like
gonna
a
put it
really
on
low
there.
grade because they don't know it, just will never know that they got a low grade.
So transfer z-score to an x-score to a raw value. Find specific data value of a normal distribution given the probability. So in other words, again, we're going to be looking at our normal curve. They're going to say, what's the z-score that goes with 50%? Well, 50% of the data is to the right or to the left. What's the z-score that goes along with that? 0. And then we might change it into a raw score and go with that. All right. So that's what we're doing. We're going backwards. If you haven't already, find those charts. We're going to use the charts first. So find the packet that I gave you that has the charts on it. In section 5.2, we were given a normal distributed random variable x, and we were asked to find the probability. In this section, we're just going backwards from that. So before we were going from the raw score to the z-score to the probability. Now we're going from the probability to the z-score to the raw score. We skipped like this middle step, right? Because we used our what? Calculators. We sort of skipped changing everything to a z-score, but you still should be able to do that using that formula for a z-score, and I think it's going to be here in a second. To find the z-score given an area, you determine the cumulative area to the left, use the chart to find the z-score. You're just using the chart backwards. I don't know that I would write any of this down. We're just going to do some examples to show you how to do it. So on your chart, again, I always like drawing a picture first because otherwise I screw it up. We know that this is our 0.
Can I share with Benjamin, or do you have a spare?
If you don't have a chart, I ran some off so that I could have them up here. If you can't find your chart, just lay them on this. Grab one. I draw this picture. I know at 0 what percentage is to the right.
50%.
It's twice today. To the left. 50%, right? I was still correct, but I was pointing in the wrong direction. So we want about 36%. So that's going to be somewhere about in here. We're looking for some z-score that's going to fall right in there. Right away, I know that what kind of z-score is it going to be? It's going to be positive or negative?
Negative.
It's going to be a negative. So it's going to be a negative z-score that we're finding there. So all I'm doing on my chart, I'm looking at this front page. And we're using the chart backwards. Instead of looking here to z-scores, we're going to look in the middle, and we're trying to find this number. And that number is not always going to be on there, so we find what's closest to it. Does that make sense? Does that make any sense? So look down through there, and I probably ain't going to be able to see it. Should be on the first page because it's a negative.
Negative 0.3 then?
Negative 0.3632. We want the one that's closest.
Negative, or it's 0.05, negative 0.3, and 0.05, yeah.
Is that number exactly on here?
Yeah. 136, 3632.
Yeah.
Negative 0.3.
Is that it right there? I can't see it. So it's right here. All we do to find the z-score is we go up to this column, over to this row, or column over here, up to this row, over to this column, and we match up the two numbers. What's the number on the left? Negative what?
Negative 0.3.
Negative 0.03. Usually I don't like that O in front, but it's just. And then what's the one up top?
0.05.
So 5. Negative 0.35 is our answer. That's the z-score that matches that area. It's that simple. It's nothing hard about it. You're finding it. Does it make sense?
Yeah.
30-some% down there, is that about where we guessed it at? Yeah, somewhere around there. We didn't really guess real close. Should have pulled this up so I could see it. So it's right there. Notice this number, we're just going to put them together. That's our z-score. So z-score is negative 0.35. A little different. Find the z-score that has 10.75% of the distribution to its right. Gotta be careful on this one. I draw my little thing here, zero's right in the middle. We want 10.75% to the right. Where am I gonna put my little line at that's representing our z-score? Tell me when to stop.
Hey,
That's,
So,
no, wait, I was thinking of the old one.
Keep on going. I'd say probably like, right
Well, it
there.
depends.
About there?
Depends on what the standard deviation.
So now what is the standard deviation? Because we're on a standard
Then one.
So
How do you know?
somewhere over here, because we're dealing with what?
You didn't tell us.
Z-scores.
This is
Find the
probably-
z-score.
I didn't read.
Well,
I can't read.
What percent are we wanting right there?
About 10.75.
10.75%. That's not, we're not gonna be able to look that up on the chart because it's not gonna help us. Because the chart tells us everything to the left. So how are we gonna find how much is to the left?
So 100 minus 10.75.
Take 100% minus 10.75%. What's that give you?
89.25.
Now, again, this number isn't gonna be on the chart because it's a percent. We want it as a what? Decimal. So what do we do to it?
Point. Move it over.
Bump over 2. So 0.8925. That's the number that we're looking up on the chart. Is it going to be on the first page? No, because what kind of z-score should we have? We should have a positive, so it's going to be on the second page. Did you find it, Brian?
Yeah.
Is it exact or is it
Yeah,
somewhere
it's
close?
exact.
Exact? So what did it come out to be?
So a number on the left is 1.2, and the number on top is 0.04.
So 1.24. Does it make sense that 1.24, does it make sense that almost 90% of the whatever scores are to the left of 1.24 z-score?
Yeah.
Yeah, if we look at our normal curve again, we got 1, 2, 3, 1, 2, 3. What percentage is in this part?
I think like 30, 34.
34. What percentage in this part, if I could draw even? 34. This part? 13.5. This part's like 2.4. This part's 13.5. This part's 2.4. And this is 0 here. We were out we're saying it's just past 1, so we're out about here. Does it make sense that 90% is that way and about 10% is that way?
Yeah.
Yeah. got it right. Brian lied to us or not. 1.24, looks about right. If you're finding something in the middle, again, draw your picture. Doesn't have to be great. Even though mine are every time, they're great, aren't they, Phoenix? Mine's spectacular every drawing. Draw your picture. We know zero's in the middle. And decide what are we going by. You know, if it's a percentage, we got to decide, okay, we want 90% in the middle, let's say. So let's just go with that, 90%. So I know it's going to probably go something like this, and we want 90% in here. Once you know that there's 90% in the middle, we did this last time, what percentage is going to be on this end? 5%. What percent's going to be on the other end? 5%. All we have to do is find this z-score. Guess what's going to be true about this one? Exact same thing except positive. So this one's going to be a negative z-score, this one's going to be a positive, but they're going to be the same number. All right? To look up 5%, 5% is 0.05. Go on your paper. Is that going to be on the front or the back? 0.05. The front page. Go on there, look down through there and find 0.05. Again, is it going to be exact? This time, probably not. Oh yeah, it is. Oh no, it's not. Can't see.
We have two options.
So what's it say? We got 0.495
and then we got 0.5 or 0.05.
So which one's closer? That's the one we're going to go with. They're both the same? So pick one of them.
505.
All right, so what's that give you? What's your z-score?
For which one?
Negative 2.
Negative 2 even?
Or no. my bad.
Negative 1.6.
Yeah.
Negative,
I misheard it, 0.
negative 1.64?
Yeah.
What would the other one have been?
1.65.
5? All of you are pretty smart. If we know it's right in the middle of these two, what would you probably guess it is?
1.6.
Sorry, that should have been 5. 1.64. If it's exactly in the middle, then do what it should be exactly. If it's not, pick one and get closest. So that's one of our answers. What's the other z-score out here? Positive 1.645. It's that simple. There's nothing hard about it. So on this one, find the z-score that has 96.16% of its distribution to the right.
Yes, so.
So to the right, we want that way. That means our z-score is going to be somewhere in here. We want this to be 96.16%. If that's the case, first thing we got to do to this is change it into a decimal. And then what are we going to do with it? Subtract it from what? Subtract it from 1 or 100. So somebody do 1 minus that. Zero what?
384.
384. Anybody else get that? Is that right or not? Grab your calculator and do it. It's not that hard. That's right. So that's the area we want right here. That's the number we're going to look up on the chart. So see if we can find that number on the chart. Again, I can't see it, so 0.0384.
Yeah.
Is
It's
it-
on there.
Is it on there?
Negative 1.7.
7.
0.07.
So negative 1.77.
7.
That's our z-score.
This ain't bad.
Find the z-score that's got 95% in the middle. I think we just did. No, we didn't do this. 95% in the middle. So we want two Z-scores, 95% in here. What percent's gonna be out here then? 2.5. We don't want 2.5, we wanna change it to a decimal, so how many places you gotta bump it over? 2, so 0.025. That's our area over here, that's our area over here. Look up on the chart, 0.025.
Negative 1.96.
Negative 1.96. That's one of our answers. Positive 1.96. Remember last class, what I tell you about those two numbers?
Those are important.
Those are going to be important. Because 95% of the data falls in the middle, 2.5% on each end. We're going to use them a lot. On your calculator,
This chart seems easy.
huh?
This chart seems easy.
Chart's easy. On the calculator, it might not be easier though. It's easier if all you're dealing with is Z-scores. When you start changing raw score to Z-score and Z-score to raw score, then you might want to use your calculator. Because then you don't, again, Phoenix, like that graphic that we had up there earlier where we skipped that middle step, well, you're going to be able to skip that middle step. Finding this on yours.
Wait, what are we doing this, what is this?
This is telling you how to do it. Using the calculator to find the Z-score. Just find it. Yep. You're holding it up, I can't see it. If I can't see this paper, this right here, I sure can't see that far. Tail right or tail left? We'll deal with that later. Not today though.
Is that what you said later?
I just
Well,
figured.
later could still be today.
Right, I didn't figure later was enough, wasn't specific enough, so I better specify a little. On the new calculators, you gotta type it in separate. I think you hit inverse norm, then the other screen pops up. Is that right, Gage? And you just gotta type in this stuff. Notice the mean, if we're on just, if we're doing a standard normal, what's the mean again? 0. What's the standard deviation? And then the area, you just put in there whatever area you want. Remember, this area always has to be the area to the left. Alright? So if we're doing this, same idea as using the chart, you're going to find the area to the left, and that last time we found that negative 1.96. But we didn't just want that number. You have to remember we also want the positive 1.96 because we're looking in the middle. Percentiles, going back over percentiles, you wondered why I threw that on the quiz. This is why. Percentiles divides everything up into hundreds. Does anybody remember if your score is in the 72nd percentile, what's that mean?
You're 72%. Or it's 70% higher. What's more? So you said we're in the 72nd percentile? My score is in the 72nd percentile?
Yeah.
You scored higher than
I scored higher than 70%.
Higher or
You scored higher than 72% of all the other people. So if we're looking on our graph and we're in the 72nd percentile, where am I going to be at if 0 is right about there? Am I going to be here?
About at 1.
Nope. That, a little bit right there.
Somewhere around in here.
About at 1.
Alright? So that means that 72% of the people, I should be on the positive side, right? I'm above average because I scored higher than more than 50%, so I'd be there. And if we wanted to find it out for sure, we change that 72% into 0.72, and we could look up that number on the chart. Would it be on the first page or the second page? Second page, and we could find our Z-score. So 0.72, if I look that up, see if I can find something
This is
close to that.
0.719.
Is there? So,
It's,
so what's that go with?
0.48.
0.48.
Yep.
So were we about 1? We're actually right at about a half. So we're just about halfway above
It's 0.58.
0.58.
40. Bo?
It's 5.8.
I guess I should keep looking shit because I can't trust it.
Yeah, you're right. I said that.
Felix, that's what I heard you say.
Yeah. And the tape got it wrong too. Like they scratched there and I said 4.
How you know what they did while you?
Because it's the elites, man. It's the Rothschilds.
The Roth.
Find the z-score that corresponds to P5. P5. So I'm on my graph here. Zero's right in the middle. What's P5 mean?
Very, very low.
5, the 5th percentile. Where's that going to be at?
Very low.
Very low, down here somewhere. Because I want 5%. I scored higher than 5%.
Good job.
So 5% is 0.05. I think we already looked that up, didn't we?
Yeah.
0.05.
It's the one where it's in the middle. So it's like 1.645, I think it was.
Yeah.
Negative 1.6.
Negative 1.645. Now, if there's 5% down that way, I probably drew mine down here too far. Should that be down around the 3rd percentile? No, because 3rd percentile, we know there's only like 2% on the outside of it. So it's going to be up farther than that, somewhere in between 1 and 2. So you just got to be able to change all these over to what you actually need for that certain problem. We want to do all these or not? Let's do the first one at least.
So yeah, let's do it.
What's the z-score going to be for that one? 0. Because it's 50%, right? So we're right in the middle. 90%, if we were going to do 90%, 0.90, again, we're looking at our little curve. We want 90th percentile is going to be over here somewhere. We want 90% of all the other scores to be on that end. So first page or second page? Second page. Could you use your calculator?
Yes.
Yeah, if we're going to use our calculator, we hit second, bars, inverse, norm. Anybody know what inverse means? The opposite. So inverse norm. And then we type in, what's our area this time? 0.9. What's our mean?
Isn't it plus standard one?
Yep.
So
0. What's our standard deviation? 1. You type that into your calculator.
.1281.
Say it again.
0.1281.
Point
But net.
Wait, no, 0.1.
1.281. Does everybody agree that our z-score 90% could be a positive 1, 1.2 something? Maddie, you're looking at it like you don't believe in. Is that what you got?
You don't technically have to put in the error or the
You don't?
when you're working with z-scores.
All right, so when you're working with z-scores, Maddie's saying you don't have to put these in. I probably put them in there just because what are we going to do next? When we do raw scores, guess what we're going to have to put in so that it understands it. All right? And I'm not sure on all the calculators. It's probably that same way on all the calculators if you just put in the area. But
Automatically puts it in.
it puts it in as a z-score, right? That's the way it gauges, I know, because his pulls that up. And to start with, they always have the mean is 0 and the standard deviation is 1. And you change it if you need to. This you do need to write down, especially this. The first one you should have somewhere, but you might want to write it down again just in case you don't have it somewhere. Or you lost it or whatever. Or you don't know where it's at. So if we're going x to z, so if we're changing it from a raw score to a z-score, We've been doing that for a while now. As a matter of fact, there was one of them on your semester exam. If we're going the other way, if we're changing it from a z-score to a raw score, so we want to find the x value, then it's mu plus z times standard deviation. Can't trick you, can you?
You just, no way you just did that, Tim.
So this next test, this is the formula you're going to have to use to see what score you got on the test.
Oh, that's so fun. What's the, you have to have the mean score of the class.
I'll put it on the board for you.
60%.
This is how you guys.
Hopefully the mean score is what?
100.
Well, I mean, that's true. That's
50.
wishful thinking. But let's
That's what for me
You
too.
said bell curve should be like seven.
We hope, but we don't hope.
should be right in the middle.
Shouldn't it
We
be
really
like
hope
zero?
it's don't, it's 50, but.
Right in the middle
Say that,
of
but
a
then-
C. What's the grade right in the middle of a C? 75. Should be a 75. Hopefully that's the mean.
The mean should be 97%.
Let's see. That's what we're hoping it is. But
Makes it more
It
work
should-
on us.
it's-
I mean, I'm hoping it's like 15%, and then when I get 100, it looks better for me.
didn't he mess with you all the time about because you screw the curve up and everything?
When you gonna get 100?
What are you gonna be 100?
That was uncalled for.
Were you talking to me?
No, I'm talking Sean. You look good.
What?
A veterinarian records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds and a standard deviation of 2 pounds. Find the weights X corresponding to the z-scores 1.96, negative 0.44, and 0. So we want to find the scores. First, I'm going to draw this. I'm going to draw a little curve up here just to have something up here. The mean is 9. Standard deviation is 2, so that'd be 9, 11, 13, 15, 7, 5, and 3. We get a cat that's down here. You take your cat into the vet and they weigh less than 3 pounds. Probably what's going to happen? That's that might be true, but before that,
Already dead.
the vet's probably going to tell you to go away and keep your cat because you're not feeding it or something, right? So you get a cat that's up here, about 17 pounds.
Quit beating the cat.
Right. Same thing might happen. The vet might say, hey, we're going to keep your cat for about a month. And then you can come back and get it because otherwise it's going to be a diabetic here pretty soon and it's probably going to die pretty quickly.
Simon's still kicking. He's like 14 and a half now.
They're both fine.
So on the first one, 1.96, we're trying to find our X score. Oops, we don't need that. Trying to find our X score. For 1.96. What do we do here? What did it tell us to do? 9, that's the mean.
Plus 1.9.
Plus 1.96 times 2. What's that give you?
12.9.
12.92. What's probably true about that cat?
They're a little more than average.
Alright, he's up here almost to the 2. He's probably okay right now. If he gets any
They don't have a dog.
chubbier,
Or cat.
Quit giving them wet.
probably not a good thing. Next one, negative 0.44. So same thing. 9 still, plus negative 0.44 times 2, what's that give you? 8.12. What do we notice about that cat? A little bit less than average, not too far, probably not too bad. And then, what about if our z-score is 0? Then what's our cat's weight? 9 pounds. We don't even have to do the math. It should work out that it's 9 plus 0 times 2. 9 times, or 0 times 2 is 0, plus 9 is just 9 pounds. You guys can handle all that?
Yeah.
Pretty easy stuff.
Pretty bad.
Dogs, we're going to skip over this one, same idea. To do this stuff, again, got to start drawing a graph every now and then, just so you know. Most of you seem like you're not too bad, but know where you're at on the graph and be able to understand it, use some common sense and say, hey, if I'm on the left-hand side of the graph, if I'm over here, my z-score should be in the negatives, and know where it should be in relationship to the raw scores. Remember that the chart always shows to the left. You can use the chart if you want. Phoenix said the chart was pretty easy, but then I seen him using his calculator, so he probably figured out the calculator is pretty easy also. Scores for California Peace Officer Standards and training tests are normally distributed with a mean of 50 and a standard deviation of 10. An agency will only hire applicants with scores in the top 10%. What is the lowest score you can earn and still be eligible to be hired by the agency? This is, a lot of companies do this. They only hire the top 10% or the top 20%. So you go in there and you take, a lot of times it's not a test like this peace officer one. A lot of times it's just one of those psychological tests, all right? Where they ask you questions. And they'll ask you a question like, have you ever stolen from a business that you work for?
Yes.
And then 50 questions later it'll say, if given the opportunity, have you ever stolen from a business? And they'll reword it. And what they're doing on part of that is making sure that Brian's answering the question, because it's the same question just worded differently, making sure he's answering it the same way. If he's answering it a different way, it's not good. That probably means that he's what? Lying. So they do stuff like that. On this, to change this score into a score's 10%, into a raw score, we want the top 10%. I didn't feel like drawing the graph, so we want the top 10%. So we're here. That means what percentage is down this way?
90.
So 90% or 0.9. We look that up on the chart, or we use our calculator. In our calculator, somebody help me out. If you guys figured out that you can just put in 0.9, type in just 0.9. I think we just did this a second ago. What's it come out to be? .28. Is that right? 1.28. So that's our z-score. Then we just change that z-score into an x-score. We take the mean. What was the mean here? 50 plus 1.28 times 10. What's that give us? 62.8. So if you're taking this test, what score do you need to make sure you're on there?
62 point. Can't you just do the inverse norm 0.9 and then use the mean and the standard deviation that it gives you in the inverse norm? Because it gave me 62.8.
Did it really?
Yes.
Oh. I don't know. Let's see. To find it. It's killing my stuff, isn't it? Here I practice this and it kills it.
I was just thinking how to do it.
That's good. So to find it, if you want to change it, you want to find the x value given the area, then you can use this. And I'm not sure why I wrote on there new calculator is the same, but no commas. I'm not sure why you don't have the commas. I'm not sure what I meant by that.
It's like in a row.
Oh, so it's up and down, so you don't have to. All right.
Literally a comma.
It's literally, it's
Yeah, well, I don't
above
have to
7.
use this comma that we have on our calculator.
Well, you can use it.
Comma 2, comma 8. Syntax. I gotta delete all my history on my calculator.
Why?
I do it every day. I delete it.
What you looking up on your calculator?
He just got used to doing it on his phone.
Yeah.
So he does it on every electronical thing now.
Yeah.
Yeah, so the government can't track it.
Your province staff.
They already tracked you.
No, they don't.
Did you get your mumps and measles shot many years ago? Yeah, you did.
If you
Yeah, you did, because you wouldn't be in school here.
I lied.
His dad forged
I got
the
a
doctor's
fake paper.
signature.
I got a fake paper.
So, what Brian's saying, and I think you said that, somebody else said it, it's got left, right, center. You can, so I think the way that is, I didn't want to say it before when somebody said it, is that's telling you, hey, where do you want this area to be? Do you want to be, and you just got to be careful because we're looking at like 5% on each end. That means 90% in the middle. Make sure you're putting in the right one. It was Riley that said it earlier.
Because if you switch it to
Isn't that right, Michael?
Huh?
Isn't that right?
That's right.
It's right, isn't it?
So that's just telling you which
Yeah.
tail, which way are you going.
The vaccine just.
So instead of you have to subtract from one, like we've been doing, it's doing it for you.
What's the central?
So the central one is where we're looking for
Sean, 3 and
No,
something.
yeah,
between those
two.
two. So we'll be looking for this. And again, that's one I'd be careful on, because then you want like, see, I probably wouldn't use the center, because I would probably say, okay, if I want 5% on this side, 5% on this side, and I want 90% in the middle, then I would just go with the 5%, find this one, and this one's gonna be the positive of that.
I like writing stuff on the calculator.
What specifically, right?
Like funny words.
On this, the braking distances of Nissan Altimas are normally distributed and have a mean of 129 feet and a standard deviation of 5.18 feet. What is the longest braking distance one of these cars could have and still be in the bottom 1%? Car manufacturers actually do this. This is part of their safety. That safety stuff that you see, that hey, this car is the safest car on the road and this one's not and this one is. To be safe, you need to be in the bottom 1% of the braking distances for that certain car. All right? Why are cars different? Why is a Nissan Altima different than maybe some other car? Weight. All right? So even though you got this great big huge Tahoe, the braking distance might be 250 feet or something, they might still consider that safe, even though it takes that long to get it to stop because it's so big. So on this, first thing we're going to do, sketch the graph. Let's see, what goes in the middle here? 129. Help me out with your calculators again. 3 on this side. What's 129 plus 5.18?
134.18.
Add another one to that.
139.36.
Add another one to that.
134.54.
On the other side, is that right?
It looked like a 9.
On the other side, subtract 129 minus 5.18.
124.82.
Subtract another one.
118.61.
Subtract another one.
was supposed to be one.
Yeah.
123?
Yeah.
Alright.
And the last one is 113.46.
4.6. Now, I usually do this when I draw my graph. I make that mark there a little bigger, so I know that that's a mean, because my graphs aren't always drawn perfect. Alright, Brendan doesn't have to worry about that, because he draws his graph perfect every time. We want to find the z-score for 1%. Well, if we want 1%, what percent of the data is going to be to this side? 1, so 0.01. Type that into your calculator and tell me what the z-score is. Negative what? 2 point, say it again, I can hear.
2.3.
2.3 is go out any farther?
2.326.
326. So we'll say 2.33. Anybody else agree with that? Yes? How are we going to find the x score? How many feet is that? Because if I tell you, hey, your Ultima has to be negative 2.3 to be considered good, that's not going to make sense to anybody. We want to know how far is it actually going to take for it to stop. How can we find that? We could use the formula. Do we want to use the formula?
No.
No, if you don't want to use the formula, then grab your calculator, and what are you going to type into your calculator?
The mean of 129 and the standard deviation of 5.18.
In that order?
No, the area should be first.
Area's got to be first. What area do we want? 0.01, right? Type that in. Again, some of you need commas, some of you don't. What's it come out to be?
116.95.
What's that telling us?
If you want to be in the 0.1%, you got to break 116.95 feet or less.
So, if your car at whatever mile per hour, they usually do it at like 35 or 55 or something like that. If your car can get stopped within 117 feet, then you're in that best 1 percentile.
I would hope it's not 35. It takes that long to stop 35. on the
Yeah, it
ground.
should.
That's
It's probably,
pretty-
this is probably
pretty bad.
55 or something.
Need good brakes.
Some good break.
Good brakes.
Yeah. Good break. Throw it in the parent.
That's your assignment.
Oh my goodness.